here we go. Oh, that's so cool. All right, guys, today I'm going to show you the different laser modes on the new FreeScan Combo from Shining 3D. Now, this is one of the best scanners that we carry. It's metrology-grade with 0.02 millimeter accuracy and down to 0.05 millimeter point distance. That's the resolution and detail you can get with it. Now, we have these in stock, ready to ship at visionminer.com/scanners. If you want to learn more, see if it's right for your application, just hit us up. We can get on a live video demo and scan something for you, whatever you want. We can pick something up, or you can even send us something. So let's get right into it. Got the software open here, and the first thing you'll see is we did the calibration. Now there's a video on that, so go check that out. And here I'm going to select between laser scan or IR mode. IR mode is going to be more for portrait, like scanning people or scanning large objects with features. Laser mode always requires the markers, as you can see we've got laid out on this table, or as we've got placed on this part, and that helps it track everything and maintain that high level of accuracy. Infrared mode uses the features, the geometry, the shapes, the asymmetry to track and maintain its orientation, but today we're going to focus on the laser scan mode. So I'm just going to click laser scan, then I'm going to click new project group, and I'm going to call this laser demo 1. And I'm just going to keep it around 0.5. Now, as you'll notice here, it only goes up to 0.1 millimeters. If I cancel out, go here and select advanced mode, then I make a new project group and I can call it laser demo 1. And now I can select the 0.05. So if you're wondering, that's where you find that. But I'm going to stick to about 0.5 millimeter resolution now, just for speed. The higher the resolution, the longer it takes to gather the points. If you think about it, we got a square inch. If I'm at 0.5 millimeter resolution, it's gathering a couple hundred points. If I go down to 0.05 millimeters, it's a couple thousand, if not 100,000 points. So it's a significantly higher number of data points, meaning you just spend a little more time doing the scanning and you go a little bit slower, and that will get you that higher resolution detail. For today, we're just gonna blast through this, and on the screen here, you can see the camera windows at the top. Now, this will show me my exposure. And if I do change the brightness down here, when the lasers are on, that's where that's affected. We're gonna use the auto exposure here, but then you've got your project groups, just like all the other Einscan scanners. It's one of the great things about Einscan and Shining 3D is their software is really streamlined. So here I can choose to scan the point cloud or the object, or I can scan the markers first. Sometimes that's advantageous if you have a bunch of markers that are set up and then you place objects in there. You can use a global markers file, and it just sort of speeds up the process and increases accuracy slightly. In general, you don't need to do that. And then here we've got either 26 laser lines, 7 laser lines, or a single laser line. Now it's mostly used for getting down holes and getting deep data. Down below that, you've got the object normal or reflective objects. The reflective object mode will actually increase the brightness and the data integrity will go down slightly. That'll be more artifacting and stuff, which is usually really easily removed in the post-processing, but it gets those reflective surfaces a lot better and faster. All right, now down below that, we've got the brightness slider, as well as the auto exposure, where I can just look at the object for 5 seconds and it'll adjust it for me. And then below that, we've got outdoor mode, as well as local enlarged view and view lock. I got my 26 lasers, normal mode. All I gotta do is either press the upper right corner play button or this little button in the center on the back. Once I press it once, I'm actually gonna put this wrist strap on because this thing ain't cheap. It is made of metal though, so if I drop it, I'm not too worried about it. And the exposure was automatic. Now it's a lot higher because it's seeing all these studio lights here, right? You know, you can scan in a dark room, you can scan somewhat outside, you usually want to be in the shade, but for the most part, you don't have to worry about lighting very much, especially with the laser mode. I'm just gonna start, and it's just gonna capture all kinds of data all over the entire object. And you can see there, one rotation of this Lazy Susan, and we've nearly got an entire part. I mean, that was like butter. I can even go to the top here and get a lot of this stuff down inside the part. Now for this, to get the holes on the sides, we will want to do a second orientation and flip it upside down, so we'll get into that in a second. But for the most part, they got pretty darn good data. Now what you're noticing is those little things down there. Now if I press the up button, I can actually zoom the view so I can really see what I'm scanning and where it's missing data. So this is a really troublesome part for a lot of scanners. And the reason is all these little way down there, most scanners are a lot wider. And so it can't actually see the laser points all the way down at the bottom because the lenses are out of view. If both lenses cannot see the area of the part, it cannot scan it. It's triangulating everything. So that's where the single laser line really comes into play. So I'm going to switch there, and you can switch on the fly too. After I do a quick little cutting plane just to save data, I can click here, select the point cloud. I can adjust the edges slightly. I'll move that up there. Let's go right about that. Hit apply, and that's going to delete all that extra data. Now all this other data here, you can see just stuff in the field. That'll all get removed when I generate the point clouds, no problemo. But first, I'm going to jump in with the single laser, one of my favorite modes, and I'm going to get all those edges. Now, why don't I just turn the part over? Frankly, it's a demonstration, and the idea is if you had a hole with like a grate or something down there, or something in an engine where it's 6 to 8 inches deep, then you can use the single laser mode to get down that hole if you can't flip the object. So same thing, just hit the button once, get the preview. You can see that laser preview, and then I'm just gonna hit the button again to start gathering data. And then I'm going to basically line this up with the face. So I'm going around, going along that edge and getting that face. And you come a little bit closer based on the left side of the screen. Then I can flip it around. This is sort of like sniping with a 3D scanner, right? Just going straight down hole, getting that data that I need. One big thing about the FreeScan is that you can see how much shorter it is than the HX, or I mean, especially the original FreeScans. Those things are huge. So the angle at which it can see where it's triangulating is much, much smaller, meaning you can get much deeper into holes than with other scanners. And if I can look at the object or the screen to kind of get an idea of where it's capturing data. Getting the data is all about finding that right orientation for very challenging and difficult areas like this, and just going over it until you get what you're looking for. Oh, there we go. See, I found that angle on that corner. See if I can get on this other one. On most parts, there will be one angle that will work. All right, it looks like we got data from there. So let me just pause here real quick. It's always good to take a quick break and examine the data that we've gathered. So we come down in here and you can see we've got these walls. Okay, so I didn't get the inside right there. So I'm just gonna go back real quick. So I can just pick it right back up. As long as I didn't move my object in relation to the markers, I can just keep scanning. There we go, see it picking up that face there? You'll also notice that this is a black part. I didn't use any sprays. I didn't use any disappearing scanning spray. I didn't use any baby powder or anything like that. I'm just scanning the black part. That is mainly a function of the laser mode. It really just has that brightness and intensity that the scanner needs to pick it up, and that is what we're doing there. Now the infrared mode also works very well on black parts, surprisingly, but that's because it's infrared light and that is reflected off the surfaces. So here we go, got a little bit more of that data. Looks like I got pretty good on both sides. So now you see all this junk all over the place. I'm just gonna click the button optimize and generate the point cloud. And the scanner just picked up millions and millions of points, and now it's going through and finding what points are like clusters of 3 in one area, and it's calculating and saying which one's actually the most accurate based on the other points around it. And it's going through and calculating all that. Now, if I look at the Task Manager performance window, these are Windows only scanners for the moment. I can look at our performance and see it is using 99% CPU and not so much the graphics card. Now that is a demonstration of how much more important your CPU is in these situations. Now RAM is sort of how much data you can scan, whereas the CPU is going to process all that data faster. The graphics card comes into play when we go and mesh the model at the very end, and we take all these points and data clouds and mesh them into an STL or an OBJ or 3DMF or what have you. But up until that point, your graphics card isn't the most important thing. And that frankly doesn't take that powerful of a graphics card. If you're doing this for business and you want to make money, and that's why you're buying one of these scanners, then I would say invest mostly into the CPU and RAM before the graphics card. If you got a GTX 2060, 3060 or above, you'll be fine. So as you can see here, it got a lot of data and it got rid of all that extra data that we didn't want. Now there is this little part right here. I don't want that, so I'm going to select it and delete it. I can also get rid of anything else that I don't even see, and I can just select part of my part, and then I can hit connected domain and then invert, and there's no data selected, so I can't delete it, but if there was, it would delete that too. Say you want to get some detail, let's just turn this thing upside down, get another orientation, and then align these two models. I'm going to apply my edit, because I deleted that data, and now I'm going to create a second project in this same project, and that's going to get the other orientation, and then we'll go align that here in a second. So we are in single laser line mode. I'm going to show you what that looks like just to start real quick, and then we're going to switch to 7 lines so you can see some of that. So here we go. Oh, that's so cool. I love this mode because it's like you just get this whole perspective data, right? You just get this whole area. So it feels more efficient some of the time just to use single laser line because I can just go, it's like a classic, paper scanner where it's like, you get that whole area. I'm gonna switch over on the fly to 7 lines. For 7 lines, you have to be a little closer because the 7 lines are actually more intended for getting high detail. And since I don't have markers on this part, it might not work so great, as you can see. So I'm just gonna switch back to 36. We're just gonna knock this out real quick, and then I'll show you about the 7 lines and how much detail that'll get. So I wanna focus on the holes here because in the other scan, we did not get the underside of these holes. I'm just gonna spend a little time here. It's got 1,000,000 points now at 75 FPS, and this is a pretty old PC. As far as specs are going, just for total transparency, that's what we do here. So we are running an i7-9700. This is about 4 years old, I wanna say. And a GeForce RTX 2070 and about 64 gigs of RAM. It's only using about 10 so far. And then I'll just go in, let me clean up some data real quick. I'll do the cutting plane again, fitting the point cloud. I can also select markers, and then I can just select 3 of these markers to make a plane. This is a new feature they added, actually, being able to adjust the plane on the fly. Boom, all right. Got that. Now let me go in here and generate point clouds again. That's going to get rid of the extra data. And then we will align these 2 parts real quick. Beautiful. Got my scan data. Let's go to the align window. Now I just select project 1, project 2 in the other window, and you can see it's not lined up. I'm just going to use by features, automatic alignment. Let's see if it does it. It's very asymmetrical, so it should have no problem at all. And it failed hard. It flipped it. So instead, we're just gonna go by manual since we don't have markers on the part. And I am going to grab, let's see, we got the same one. I wanna orient them the same. So I'm gonna hold shift and I'm gonna click there, 1 and 2, and roughly the same spot, 1 and 2, and then 3 on that one. And apply. There we go, perfectly aligned. You can see it's filling all that data in. Hit next, that saves it as the alignment, and then I exit. And as you can see here, if I select both projects, you get one big part. And you can see all the markers and everything there too. Now I can turn those off if I just want to focus on the actual data. And we've got our scan. So you can always go back, and it looks like I missed a little bit in there. I went too fast in the second half, but for the most part, if you're gonna reverse engineer this part, we're done. This is plenty of data. You can take this and mesh it. So I can go here, I can go no filter if I'm doing reverse engineering because it's not gonna smooth anything, it's not gonna change the data, and I can hit apply, and that'll bring me to this screen where I can then look at it, say that looks good, perfect, confirm, and now I can do simplification. So I can take this down from 44 megabytes down to 0.45 megabytes and make a low poly version. I can optimize the mesh, which will even out all the triangles. I can smooth it just by a percentage, or I can remove little floaters if there's other data and artifacts there that we don't want. I can fill holes automatically or manually, and I can add another cutting plane if I want to slice it in half. There's also the option over here to do some basic measuring, And on that, you can also create features and do some other things. As for measuring, it's a little bit. You got a first point to a second point and a distance. You can do that anywhere on it. Boom, boom. Okay, no big deal. You can also do surface area or volume if it's a watertight part. Here, you can also create features like planes. So if I click, I'm going to use the 3 points fit. I'm going to give this a plane here. Create a plane. So now we've got that. I can also make points or lines, and then I have feature lists. And that's going to help in the next phase, the next program, to sort of align your model to the world plane and whatever CAD program you're using. Now, if you're using CAD, you're gonna need something in between this software and the big mesh and point cloud data to get it into SolidWorks or Fusion 360 or Solid Edge or what have you. You need something in between. If you're using Rhino or ZBrush, you're fine, because those programs can handle giant mesh files, STLs, OBJs, etc. Big triangulated point clouds. But if you're in SolidWorks or Fusion, etc., then you're pretty much gonna have to get something like Geomagic Essentials. Now, Geomagic is a $20,000 software suite that does everything. It's incredible, cream of the crop, top of the line. But we have Geomagic Essentials available, which is only $3,000, or you can buy it as part of the bundle and save even more. But that has all the key tools that you need for working with point cloud data and scan data. Now, there's also the in-betweens from Geomagic Control X, which is more about inspection and automating inspection. So with this metrology scanner, you could have 200 or 2,000 of these parts, and you need to make sure they're perfect because it's aerospace and it's in production. And so you can set up a turntable, set up a tripod, scan every part, and then chunk all that data into something like Control X and have it automatically generate printouts of heat maps and tolerances, and it'll tell you, however you want, where it's in spec, where it's out of spec, etc. So that's Control X, and you got Geomagic Wrap, got a few others. Geomagic for SolidWorks, which is a plugin that takes Geomagic straight into SolidWorks. So you're working in SolidWorks with the tools of Geomagic. That one's really cool. But if I want, I can just go right here and go third-party software and open Geomagic Essentials. All right, and it opens up Geomagic with your data straight from that software. It always asks, do you want to use Mesh Doctor? Yes, you always do. So we'll go into Mesh Doctor. It's going to find a bunch of intersecting faces and non-manifold edges and all sorts of stuff like that. As you can see, a lot of spikes. And then you can just hit OK, and that's going to fix those automatically. Now here, I could go in and I could use all the tools from Geomagic, the cream of the crop, best of the best in the industry standard software for this. And I can go right here, fill single, and I can select my tangent, flat, or curvature, and just click and fill in those holes if I want. Or I can fill them all automatically. There's a lot of different ways to do it if I want to. And then I can unclick that, and then you can go into here and say I want to get these planes to match something up. I'm making something that's mating on the other side of this. So I can use the crease angle selection tool and just grab this face with the click of a button very easily. Boom, right there. Oop, that's too much. Let me go back down a little bit. Boom, I go into model, I create a plane, best fit plane, and I'll label it datum C plane 14. Why not? Hit apply, and that will make the plane. And then I can also look at my deviations and get a heat map right here on the fly of how in spec intolerance that is. Now this is a 3D printed part, so if you're 3D printing for production, having one of these can be very useful to make sure that your parts are within dimensional accuracy before sending them to your client. Now I could go in here and I could also do, the same tool, and I could use the crease angle selection tool, and I want to let's grab this whole cylinder, and I'm just going to grab this area because I want to get the ring around the whole bottom. Okay, I don't want that lip, so I'm just going to keep it to there. Got another little lip area, got that. Then I can go back up the model, cylinder, best fit. And it might be a cone, it might not be a cylinder, but you get the idea. Hit apply, and it's gonna create that cylinder perfectly right around that. You could also do the inside if you wanted. And then these are all gonna be exported in a step so you can have all the features and import that directly into your CAD program. All right, so now we got the inner diameter. I could also get this other outer diameter, and I could get these planes and those planes. And you can basically build your whole part in this and then import that into CAD and then build it based off those features. Most CAD programs cannot handle big mesh files or point clouds, they just crash. So that's why you need something like this. If you're doing reverse engineering or design, definitely let us know and we'll get you set up with the Red Bundle, Geomagic, or one of the better versions depending on what you're doing. So we'll get out of here real quick. Let me close this out. I'll save this and I'll have one of the guys upload it, and there should be a link in the description below to this file so you can sort of see the data. All right, so now I'm just gonna go back to laser scan mode. I'm gonna delete the mesh, yes, get rid of all that data. Let me know in the comments below, what do you want us to scan? What do you wanna see? What do you wanna experience with these scanners through our YouTube channel? Vicariously through our actions. We had one guy bring in an overhead bin from an airliner the other day, and we scanned that. Worked out great. We ended up using this one because it was the most compact scanner to get down in there and actually scan from inside the box up at the upper lip. So sometimes size matters and you want it to be small. All right, guys, so that's the brief, long overview of the laser modes for the FreeScan Combo, the latest and greatest metrology scanner from Shining 3D. Available in stock now, ready to ship tomorrow at visionminer.com/scanners. Now, if you're still confused and you don't know which one should I buy for what I'm doing, call us. Give us a call, shoot us an email, let us know what you're doing. We'll get on a live video demo with you and do something similar, or you can even send us your part and we'll do it there, because I want to make sure that you know exactly what you're getting and that it will work before you buy it. So we're here to help. Thank you so much for watching. Have a positive rest of your day, and I'll see you on the next video.